Hey, this is Mr. Ward, and I'm going to do a series of quick videos on questions from the 2019 Math MCAS for 8th grade. And I'm going to start with number 1, and I'm going to actually go through and look at the other exponential ones. I think this video will focus on the exponential questions. So this very first question has to do with scientific notation, and we're trying to turn this scientific notation into standard notation. When we say standard notation, all we're saying is turn it into a number. So scientific notation has two components. We have this 8.25 part, which we call a coefficient, and this power, 10 to the 5th power. 10 to the 5th power is just telling us what the place value of 8 is. So let's think about what 10 to the 5th power is. 10 to the 5th power is 10 times 10 times 10 times 10 times 10. It's telling us we're using the factor 10 5 times. And 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000, times a fifth 10 is 100,000. So that's 100,000. And what that's telling us is this 8 is really representing an 800,000. And the 2 is in the 10,000s and the 5 is in the thousands place. So 8.25 times 10 to the 5th power is going to equal 825, because 1,000. And that is it in standard notation. So a thing to notice, the power is positive. So what that'll mean is we will move the decimal 5 places to the right to represent that we have made this 8.25 100,000 times bigger, or 10 to the 5th times bigger. And that is the answer for this. If you're doing it on this bubble test paper version of it, you'd put a 0 there, you'd put a 0 there, you'd put a 0 there, and then you'd put a 5 and a 2 and an 8. And then you go down here and fill in the various bubbles. But you're probably doing this electronically on a computer, so you probably won't need to do that. And I assume you'll have instruction on that. I'm going to pause the video and go and see what other exponential questions are in here. Okay, number 3 on the 2019 test for 8th grade has another exponential question. And this one is more about trying to follow the order of operation when exponents are involved. And it also gets a little into the laws of exponents. Now, I will also note that this is trying to pretend to be an exponential function. So if you get into exponential functions in your Algebra 1 class and Algebra 2, you'll run into structures like this. But for now, all you need to know is that we're doing 5 times the cube of 2. That means 2 to the 3rd power. But it's actually times the square of the cube of 2. So the square means that we're using this 2 to the 3 as a factor twice. And the 3 means that inside the parentheses, we're using 2 as a factor 3 times. So overall, we're going to be using 2 as a factor 3 times twice, which means we'll be using 2 as a factor 6 times. So whenever you see something raised to an exponent, and then that expression raised to an exponent, you can just multiply the exponents. So 2 to the 3rd to the 2nd means 2 to the 6th. So you could figure out, okay, what's 2 to the 6th? And I'm going to go ahead and set that up in a text box here. That works a lot better for me than trying to draw with my finger on the pad. So I've got 5 times 2 to the 3rd to the 2nd. And I'm going to just focus on this part, the 2 to the 3rd to the 2nd. So let's separate that out. We'll deal with multiplying that by 5 in a second. So this is the same as 2 to the 3 times 2. That's what that is, which means it's the same as 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2, which becomes, okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, another way you could have dealt with all of that stuff in the middle is figure out first what's 2 to the third. Well, I've got that here. 2 times 2 times 2. Well, 2 times 2 is 4, times another 2 will be 8. So that's another way you could approach this. So that's 8, and now that's 8 to the second power, which equals 8 times 8, which is 64. So now let's go back to the 5 because it was originally times 5. So it's 5 times this business, and this business became times 64. And then 5 times 64 is going to be 320. And I'll tell you a sneaky trick about this. 5 times 64 is the same as 5 times 2 times 32. Because if I split the 64 into 2 times 32, now I can regroup that as 10 times 32, and 10 times 32 is easier to think about. It's 320. So our answer is this one right here. Okay, so that is that question. Let's pause and go to the next. Okay, we are at number 7 from the 2019 test. We have another exponential question. This exponential question involves it involves scientific notation and a scientific notation operation. So we're given this word problem. The speed of light in cold air is approximately 3 times 10 to the 8th meters per second. And the speed of sound in cold air is approximately 3 times 10 to the 2nd meters per second. The speed of light in cold air is how many times the speed of sound? So what we're going to be doing here, we're going to think about, we've got one speed and another speed, and we want to know how many times the faster speed, 3 times 10 to the 8th is, than the slower speed, 3 times 10 to the 2nd. If you want to find out how many times something goes in, we're talking about division. So we're talking about speed of light, okay, divided by speed of sound. So let's do that here. So speed of light, we've got that as 3 times 10 to the 8th meters per second. Okay, meters per second. It is useful to, of course, do units. And that's going to be divided by, I'm just going to put a line here, divided by the speed of sound. The speed of sound is going to be 3 times 10 to the 2nd meters per second. Okay, so when we're dividing scientific notation, actually the whole point of scientific notation is not to be able to write numbers in a new way. I mean, it's helpful, but the real point is to be able to do operations quickly with numbers. So what we can do is we're gonna separate out. We're gonna separate out the 3 divided by 3, and the 10 divided by 8th, and the 10 divided by 2. The meters per second is just going to go away. That's just getting canceled out because it's meters per second over meters per second, so we won't care about that. So we can just do all the operations separately. So 3 divided by 3 is 1, and then that's going to be times 10 to the 8th divided by 10 to the 2nd. Since this has 8 factors of 10, and this has 2 factors of 10. If we wrote them all out, 10 times 10, times 10 times 10, times 10 times 10, times 10 times 10, times 10 times 10, over 10 times 10, we would factor out 2 of them from top and bottom, from numerator and denominator. So that means that we are taking away 2 factors of 10 from 8 factors of 10. That means you can actually write the exponent like this, 10 to the 8 minus 2. And this works because it's the same base. 10 is the same base being used in both cases. We've got 8 factors of 10 divided by 2 factors of 10. We will be left with 6 factors of 10. So the answer here is 1 times 10 to the 6 times faster. That's 1 million times faster. The speed of light is 1 million times faster than the speed of sound. Okay, I've moved on to number 8, which is another exponential question, and I'm going to use the text box to illustrate this. This is a laws of exponents problem. And one of the things there are several laws of exponents. If you have, let's say, the same base raised to, let's say, raised to the n power times that same base raised to the m power, what I'm saying is I have n factors of b and m more factors of b. So that's just going to equal b to the n plus m power. And if I have b to the n divided by b to the m power, that's just the same as taking m factors of b away from n factors of b. So that'll be b to the n minus m power. So you subtract when you're dividing. If you have the same base, you can subtract the exponents. If you have the same base and you're multiplying, you can add the exponents. So we have multiplication in the top, and let's deal with that. So that's going to be 3 to the negative 2 plus 3 power. So I'm going to say negative 3 plus 2 for my numerator. And then I'm dividing that by 3 to the negative 1. So I could just subtract negative 1 from all that. But I'm just going to deal with the numerator first. The numerator is going to be 3 to the negative 1 power. I'm sorry, I wrote that wrong. You're probably saying, hey, Mr. Ward, what were you thinking? That's 3 to the negative 2 plus 3. So we're going to start that over. So negative 2 plus 3. So I'm adding the exponents of negative 2 and 3. And so I get 3 to the first power. Negative 2 plus 3 is 3 to the first. And now I'm going to be dividing 3 to the negative first by, 3 to the first by 3 to the negative first. So this numerator here became 3 to the first. My denominator, which was 3 to the negative first, I am going to be subtracting the exponents. So the whole thing becomes 3 to the first minus negative 1. And 3 to the first minus negative 1 is 3 to the second power, because if I subtract a negative, that's the same as adding a positive. The other way to think about this is in a couple ways. Subtraction is how far two numbers are apart in the direction of the first number. How far are 1 and negative 1 from each other? I believe you can imagine that 1 and negative 1 are 2 apart from each other. And 1 is positive, so it's in the direction of the first number, so it's positive. So 3 to the 1 minus negative 1 is 3 to the second power, which would equal 9. Now, another way to think of this is I've got 1 and subtraction is reduction, so I'm reducing the negativity by 1. That means I'll be going up by 1. So I'm reducing my negativity by negative 1. So, or should I say I'm subtracting negative 1 is like reducing negativity by 1, I should say. And so if I'm reducing negativity of 1, that's going to mean it's going to go up by 1. Okay, so hopefully that helped with that one. Let me see if there are any more exponential questions. And it turns out there are no more exponential questions on this particular test. So I'm just scrolled down to the end to remind you that there is a reference sheet at the end that you'd want to take a look at and make sense of. It has formulas. And also on these release tests, there's an answer key for everything except for the open response. So SA stands for short answer. SR is selected response. That could be multiple choice or multiple select. And CR means constructed response. That's the so-called open response or word problem. So those don't have answers, but you can find the answers at the end. All right, I hope this has been helpful, and I will make a video about some of the other stuff.